What if the tiny gland at the center of your brain is both an ancient symbol of inner vision and a practical regulator of your daily life? Descartes called it the seat of the soul. Modern science calls it a light-sensitive clock. Why is this small organ so obsessed with light? Welcome to Beyond the Mind. Today we'll take a careful, calm, and evidence-aware 20-minute tour of the pineal gland, where it sits, what it does biologically, why it evolved from a surface light sensor in some animals, how cultures turned it into the third eye or Ajna chakra, and what practical, safe steps you can use to align it for better sleep and clearer days. I'll also address popular but speculative claims, particularly the idea that the pineal produces DMT, and explain what the science actually supports. If you want to check sources later, I've listed core references at the end. Let's begin with simple anatomy. The pineal gland is a small, pinecone-shaped endocrine organ tucked deep in the center of the brain, between the two hemispheres near the thalamus. In most adults, it is only a few millimeters to 1 centimeter in size. Despite its modest volume, it functions as an important hormonal node. Its principal and best documented role is the synthesis and secretion of melatonin, the hormone that signals biological night to the body. Melatonin production follows a daily rhythm, low during daylight, rising after dusk, peaking in the middle of the night, and falling toward dawn. That nightly melatonin pulse helps regulate sleep timing and communicates night to tissues across the body. This isn't speculative, it is the core, well-established endocrine function of the gland. Classic and modern reviews on melatonin biology. How does the pineal know when to release melatonin? The answer is light and an exquisitely wired pathway. Light that enters your eyes activates retinal cells that send timing information to the brain's master clock, the suprachiasmatic nucleus, or SCN, located in the hypothalamus. The SCN integrates day length and light intensity signals and relays a timing message to the pineal via a multisynaptic pathway that includes the sympathetic nervous system, a special class of retinal ganglion cells. Intrinsically photosensitive retinal ganglion cells containing melanopsin are particularly effective at signaling blue-enriched light to the SCN. That is why evening exposure to screens and LED lighting, which are rich in short wavelength blue light, powerfully suppresses melatonin and delays sleep onset. In short, light reaches your eyes. Retinal pathways inform the SCN. The SCN tells the pineal, and the pineal releases or withholds melatonin in response. This is the biological mechanism that ties external light-dark cycles to internal hormonal timing. To put the pineal in context, think of it as one instrument in a larger circadian orchestra. The SCN is the conductor, keeping time with molecular feedback loops inside cells. The pineal converts a central timing cue into a hormonal night signal, melatonin, that other tissues can read. When this system is synchronized with the external day-night cycle, sleep is efficient, metabolism runs on schedule, mood regulation is more stable, and cognitive performance is optimal. When timing is disrupted by shift work, jet lag, or heavy evening light, health consequences can follow. Poorer sleep, daytime sleepiness, mood changes, and metabolic misalignment. That link between circadian disruption and health is a major reason sleep researchers emphasize light management as a clinical and preventive tool. Now a brief evolutionary detour that helps explain cultural symbolism. Many non-mammalian vertebrates retain a parietal or third eye, a surface light-sensitive organ on the skull roof that helps gauge day length and shadows. In animals like some lizards and the tuatara, this parietal eye is visibly light-sensitive and connects to the brain's pineal complex. Over deep evolutionary time, mammals internalized that system. The surface photoreceptor receded, but the neural pathways for light-based timing persisted. This ancestral history makes the pineal a descendant of a literal third eye. and it explains why human cultures often associated a central head organ with light, vision, and inner sight. The biological continuity between a surface photoreceptor and an internal gland provides a neat explanatory bridge between anatomy and myth. Culture layered rich symbolic meaning onto this biology. In the 17th century, René Descartes speculated that the pineal might be the point of contact between body and soul, partly because it is a single, unpaired structure in the middle of the brain. In many Eastern traditions, the Ajna chakra, commonly called the third eye, is described as a center of intuition, insight, and non-dual perception. Egyptian iconography, the Eye of Horus motifs, and other symbolic systems echo similar themes. Those images can be powerful signposts for contemplative practice, inner focus, and moral orientation. But it's important to keep the domains distinct. Symbolic frameworks give meaning. Biology describes mechanism. Both can be true and valuable without collapsing one into the other. Let's address a highly popular modern claim that the pineal gland produces dimethyltryptamine, DMT, in significant amounts, and that DMT might underlie mystical experiences, near-death visions, or dream imagery. This idea was popularized in the 1990s and early 2000s and has become widespread in speculative writing. The careful, evidence-based position is this: trace molecular machinery related to DMT biosynthesis has been detected in some brain tissues in experimental settings, and DMT exists in peripheral tissues of some animals. But robust, reproducible evidence that the human pineal synthesizes and releases physiologically significant concentrations of DMT during waking, sleep, birth, death, or mystical states is currently lacking. The DMT pineal hypothesis is intriguing and culturally influential, but it remains speculative. If you value verifiable claims, treat this idea as an open research question rather than established fact. So what does this mean for daily life? Because the pineal's melatonin rhythm is fundamentally light-driven, managing your light exposure is one of the most reliable, evidence-based ways to support sleep health and circadian alignment. Here are actionable, science-backed principles. Anchor your day with morning light. Exposure to bright natural light within the first hour after waking helps shift and stabilize your circadian phase. Even 10 to 30 minutes of outdoor morning light makes a measurable difference. Minimize bright, especially blue-enriched light, in the evening. Warm, low-intensity lighting and limiting screen use in the hour or two before bed preserves melatonin onset and facilitates sleep. Keep a consistent sleep schedule. Going to bed and waking within a roughly consistent window reinforces circadian coherence and melatonin timing. Use exogenous melatonin thoughtfully. Melatonin supplements can be useful for specific conditions, like jet lag, some circadian rhythm disorders, or short-term phase shifts. But they are a pharmacological signal and should be used with awareness and, ideally, clinical guidance. Now I'll lead you through a guided micro-practice I call the Safe Morning Light Protocol. It's designed to entrain your circadian system safely and practically. Important safety notes first. Do not stare directly at the sun. If you have serious eye conditions, consult an eye professional before changing sun-facing routines. The protocol gives you circadian benefit without retinal risk when done sensibly. Safe Morning Light Protocol. Step by step. Within 30 to 60 minutes of waking, go outside or stand by a bright, unobstructed window. Natural morning light is best. If that's not possible, very bright indoor lighting near a window is a reasonable alternative. For 5 to 15 minutes, allow morning light to fall on your closed or partially open eyes. You do not need to stare at the sun. Light transmits through closed eyelids and still stimulates the retinal photoreceptors that entrain your SCN. If the sun is low on the horizon and you choose to take a brief glance, keep it to a few seconds and avoid sustained direct gaze. Remember, safety first. The closed eye method avoids retinal risk entirely and remains effective. While you receive the light, take 3 to 5 slow deep breaths, inhaling for 4 counts and exhaling for 6 counts, letting your shoulders relax on each exhale. Offer a gentle intention as you breathe. I anchor my clock to natural light. Keep the intention simple and present tense. After the light exposure, avoid bright screens and high-intensity blue light for at least 30 minutes. Let the natural day unfold. This short practice punctuates your morning with a biological signal that suppresses melatonin and aligns your internal clock to the environmental day. Over several days, most people report clearer morning alertness and improved sleep onset that night. For those who want structure, here is a 7-day plan to try this practice and support pineal timing more broadly. Day 1. Begin with the safe morning light protocol for 5 minutes. That evening, dim lights and avoid screens for 1 hour before bed. Record your bedtime and a 1 to 5 sleep quality score. Day 2. Increase morning light exposure to 10 minutes. Continue evening dimming. Keep wake time within 60 minutes of the prior day. Day 3. Maintain morning light for 10 to 15 minutes. Add a short walk in daylight if possible. Continue evening screen reduction. Day 4. If you travel or work late, this is a checkpoint. Prioritize morning light the next day and avoid late bright light for the next 2 nights. Day 5. Continue the morning practice and add a short mindfulness breathing practice, 3 to 5 minutes, after the light exposure to anchor attention. Day 6. Keep consistency. If using melatonin for short-term jet lag, consult a clinician and use minimal effective doses timed to your desired phase shift. Day 7. Review your recorded sleep quality and daytime alertness. Look for trends: clearer mornings, earlier sleep onset, reduced nighttime awakenings. Even subjective improvements are meaningful indicators that circadian cues are aligning. A few troubleshooting points and safety cautions. If you experience increased daytime sleepiness when you introduce brief nighttime awakenings or experimental schedules, scale back practices and prioritize total sleep time. If you have a diagnosed sleep disorder, mood disorder, or complex medical condition, consult a clinician before making major changes or taking melatonin. If any practice produces persistent sleep disruption, vision issues, or severe mood shifts, stop and seek professional advice. Let's briefly explore a few additional scientific and clinical notes that deepen context. Pineal calcification. The pineal often calcifies with age in many individuals. The implications of calcification are still under study. Calcification is common and not itself diagnostic of disease, but researchers investigate whether heavy calcification correlates with altered melatonin rhythms or other health outcomes. Current evidence does not support alarmism. It supports measured inquiry. Seasonal affective patterns. Because melatonin signals day length, the pineal is relevant to seasonal mood changes. Light therapy. A clinical protocol using bright light boxes in the morning can alleviate seasonal depressive symptoms for many people. This intervention targets the same retinal, SCN, pineal circuitry we've discussed. Research frontiers. Scientists continue to study how melatonin interacts with immune function and metabolism in complex ways. The DMT hypotheses are being explored, but remain far from established. New imaging and biochemical methods are refining our understanding of pineal physiology and interconnections across the brain. Before we finish, here are 3 practical tips that synthesize the science into daily habit. Tip 1. Prioritize morning light every day. Even if it's only 10 minutes, consistency beats intensity. Tip 2. Create an evening light ritual. Warm lamps, no bright screens for the last hour, and a 5-minute wind-down routine to signal safety and rest. Tip 3. Use melatonin only as a targeted, temporary tool under guidance. It's not a substitute for consistent light management and sleep scheduling. Now, a short closing experiment you can try if you want measurable results. For 7 days, follow the safe morning light protocol for 10 minutes each morning. Avoid screens for an hour before bed, and keep your sleep and wake times within a 60-minute window. Each morning, record 2 simple measures: a 1 to 5 rating of sleep quality and a 1 to 5 rating of daytime alertness. After a week, compare the trend. Many people notice clearer mornings, quicker sleep onset in the evenings, and a steadier daytime focus. Small, consistent changes in light exposure have surprisingly robust effects on circadian timing. Finally, a balanced perspective. The pineal gland is both a real, measurable biological clock component and a powerful cultural symbol. Appreciating both dimensions lets you use scientific tools, light management, scheduled routines, judicious melatonin, while also honoring contemplative practices and symbolic frameworks that enrich meaning and motivation. In practice, use the biology to care for your sleep and health. Use the symbolic to deepen presence, ethical orientation, and the sense that your inner life matters. If this episode helped you, please subscribe to Beyond the Mind for more grounded explorations that bridge ancient practice and modern science. Like the video if you learned something new. Tell us in the comments. Will you try the safe morning light protocol tomorrow? If you'd like a printable 1-page routine for morning light and evening dimming, or a bibliography with direct links to the studies I mentioned, write PDF routine in the comments or check the description. Take a moment now. Inhale slowly for 4 counts. Hold for 1. Exhale for 6. And notice the quality of your attention. Imagine a calm, steady light aligning your body clock. Thank you for watching. See you next time on Beyond the Mind. Selected references and recommended reading. A Learner, A.B. and Colleagues. Early Biochemical Identification of Melatonin. Writer R.J. Reviews on Melatonin and Circadian Biology. Reppert S. M. and Weaver D.R. Reviews on the suprachiasmatic nucleus and circadian coordination. Brainerd G.C. et al. 2001 and Burson D.M. et al. 2002. Foundational work on melanopsin containing retinal ganglion cells and blue light sensitivity. Wright K.P. Jr. et al. Studies on entrainment to natural light, dark cycles. Strassman R. Exploration of the DMT hypothesis, noted as speculative. Clinical reviews on light therapy and seasonal mood disorders. Current sleep medicine reviews on melatonin therapeutics.